welcome back to those of you who were with us last week for the webinar, and welcome to those of you who are joining in for the first time. So this is the first day of a two-day workshop, Marine Data for Africa, organized by the Copernicus Marine Service, which is implemented by Mercator Ocean International. My name is Lillian Diarra, and I am a communication and outreach officer at Mercator Ocean International, and I'll be moderating the session with Ergane Fouchet. Ergane, would you like to present yourself?
Yes, hi Lillian, hi everyone. So I'm Ergane Fouchet, I'm an ocean engineer at Noveltis, which is a French company providing innovative solutions in the fields of space, environment, and sustainable development. And so I'm very excited to present this workshop with you.
Thank you. Let's hope that this time around there'll be no internet crashes.
Yes.
Okay, so just some Zoom housekeeping, if my screen, okay, some Zoom housekeeping rules. So for those of you who'd like to listen to the workshop in French, you have the interpretation icon at the bottom of your screen, and you can just select French. Please look at the chat from time to time, because we will be putting in some links and some information as we go along. Please feel free to use the Q&A at the bottom also of the screen. You can put in questions at any time, either to the floor or to a certain speaker. And at the end of each part, we will have a dedicated Q&A session. So as I said, yeah, there's a Zoom Q&A, and you also have a possibility to submit questions on Slido. There's the QR code, and my colleague will share the link in the discussion. So you can also submit your questions there. And the good thing about Slido is that you can actually vote. You can like questions, certain questions, and that way they have more weight. And then during the dedicated Q&A session, we will answer these questions first. Okay. So now pass over to Ergane, who will go over the workshop material. Ergane?
Yes. Can you see my screen?
Yes.
Okay, so all the material available for the workshop is available on the Padlet. So the link will probably be in the chat. And so in the Padlet, you can find several sections. So here is the introduction, and you have a cell here where you can pin your location and tell us where you're from. And during the coffee break, we will have a look and see where all the participants are from. So go pin your location on the map. Below in the introduction section, you can find the material of the webinar. So the event that happened last week. So you have the replay videos of the webinar and also the PDF presentations. You can find a section with all the information about the Copernicus Marine Service, how to register, how to search the products, how to download the products, and how to find the information on the products. You can have a look at the e-learning materials. So all the previous videos that have been produced for the former events. So these are exercises on Python, QGIS, etc. You will also find the material, the exercises that have been developed for this event, Marine Data for Africa. They will be available tomorrow before the second session. And you also have a link to the webpage dedicated to the Jupyter environment, which explains how you can use the Jupyter environment. You have several videos about the products. They are very precise videos, very technical. And finally, you can find the use cases that have been presented during the webinar last week. And they show examples of how to use the Copernicus Marine Service products. So that's it for the Padlet. You can go back to the presentation, Lillian.
Hold on. Is it not working? I lost the partage. PowerPoint. Okay. Let me see what's happening. Can you see my screen?
Yes.
Yes? Okay. So let's go to the slide. No. Okay.
Okay, so as I've said, you have several materials that are available for this workshop. You have the Jupyter notebooks that go with the videos that explain how to practice on Jupyter notebooks. You will have the tutorial videos recorded by the experts. You will have other training videos, so about GIS Service Desk, what I presented in the Padlet. And you will also find the user manual with all the links. The Jupyter notebooks will be available on the Copernicus Marine Service Jupyter Lab, and it's completely free. You just have to be registered to the Copernicus Marine Service. And if you're not, you can register for free. And that's it.
Would you like to share your screen so you can do what? No?
No, I don't think so.
Okay. No, I thought maybe you would want to present the Padlet, but it's okay. I think you did a good job already.
Thank you.
Okay. So I'm just going to present the agenda, today's agenda. So part one, we will be looking at modeling products. So we have the biogeochemical model and the physical model. And we also have a look at sea surface temperature observation products and ocean color. So this will be followed by a Q&A session where we will look at all your questions. And then we have the second part, which will start about 10:55 CET. We will look at observation products in situ and sea level. And we will finish with modeling products, looking at the wave model and the global reanalysis model. And this will also be followed by a Q&A session. So without much further ado, let's go to Marie Drévillon, who is the manager of evaluation of ocean forecasting systems at Mercator Ocean International, and she will be giving a presentation on the physical model. Okay, let me stop sharing my screen. Marie, the floor is yours.
Thank you. Good morning, everybody. Okay, so now you should see my screen. Is it working fine?
Yes, it's working fine. If you could just make it in presentation mode, please.
I did, but it should be. Okay, fine.
Now it's working.
Perfect.
Yes, perfect.
Okay. So as Lillian said, my name is Marie Drévillon. I'm working mostly on validation at Mercator Ocean International for the Copernicus Marine Service. And today I'm going to show you one of the products of the Global Monitoring and Forecasting Center, which is led by Mercator Ocean. We are doing a lot of activities around modeling and data simulation of the global ocean. Also, we are monitoring the ocean, validating, doing scientific studies with a lot of partners around Europe. And as you can see here, this is the list of products that we are delivering within the Copernicus Marine Service. And I'm going to talk about, so my colleagues are going to talk about products of the global MFC2, Coralie and Simona. But I'm going to focus on the high resolution products for the physics, which are analyses and forecasts at 9-kilometer horizontal resolution, and also global reanalysis with the same horizontal resolution for a long period of time from 1993 to 2020. So I hope the sound is all right, because I have a message telling me my internet connection is not so good. So
we can hear you, don't worry.
This slide is just to say that the Global Monitoring and Forecasting Center, its teams work around Europe, but within this, the work on the global high resolution is also teams work involving a lot of people within Mercator Ocean, and also partners and subcontractors. So it's a lot of work and a lot of people involved. So if you go on the My Ocean viewer on the Copernicus Marine website, you can have access to nice images of surface currents and forecasts And here you can see around Africa, you have a lot of, strong currents in the tropical areas. You have jets here, and you can see nice mesoscale features in the Madagascar channel, and then the Agulhas current, the retroflexion. Okay, so to get these nice features, we use a model. We use the NEMO model, and we assimilate observations, all the observations that are available mostly, surface temperature from satellites, sea level anomalies, temperature and salinity profiles, and also sea ice concentrations in the polar areas. But for the tropical areas, it's not so relevant. But you have to know that these observations are used in a multivariate way. So we take advantage of all observations and we use their statistical relationship in some sort. So it's a very complex system, taking advantage of all available observations and putting the information into a model, which is NEMO. And at the surface, we are using operational forecasts from ECMWF. We do a simulation once a week, but we update the forecast every day, up to 10 days. So as I said in the beginning, we also deliver a reanalysis at high resolution from 93 to 2020 now. It's no longer 2019. And starting in 2019, we are using ERA 5 forcing. So the forcing changes because ERA interim is no longer available. So you can find information on the website, of course, on the catalog, but you can also have access to more detailed information in a recent publication from Lelouch et al. 2018. This is for the new real-time analysis and forecasting system. There's also a publication on the reanalysis I will talk about later. To ensure that these products are have skill and have a good quality over the globe, we do regular validation, and this is for surface currents. What we do is we try to compare as much as possible with observations, all the observations that we have. And here we are looking at a comparison with surface drifters, from which we deduce velocities at the surface or near 15 meters. And we do systematic and regular comparisons. This is 1 year of data, and we have compared here. We are doing a correlation, a vector correlation between the model velocity and the observed velocity. And what you can see here is that the correlation is quite good all over the globe. You have something like on average is 0.6, 0.7. This is significant. This is a good skill for the model. And around Africa, you can see that in the tropical areas, the correlation is very high. So the model has good skill in general. But we are not doing only delayed time validation, looking at 1 year of data with data of the past. We are doing regular validation every day. And we are putting online a series of information. This is what I'm showing here. If you have a look at the product quality dashboard, which is available from the Marine Service website, you can have access to recent statistics, comparing observations with model outputs. And this is a time series of salinity errors. We have compared salinity profiles with the model counterparts. And you have here the dotted line correspond to a bias, a mean error, within a specific area in the tropical Atlantic Ocean. And you also have quadratic errors for several different types of products, the analysis and the forecast at different time, different lengths of forecast, 12 hours, 60 hours, 108 hours. So this way you can see if the error grows a lot in between the analysis and the forecast. And you can check if in a period of time, in a given period of time, what was the error in this area. So you can see the error is not constant. It's changing in time, mostly because the observations available at one given period of time changes. So here, as we are looking at profiles moving into the ocean, we see the error changing in time. The salinity errors are not very high. They are really dependent on uncertainties in the atmospheric forcing and river inputs. So if you look at river outputs, at river plumes, you will see more errors, of course, than if you look at the open ocean on a large area. And here another illustration is a correlation of currents. This is again in a tropical Atlantic Ocean. And you can see that the correlation of currents is around 0.6 in that area, as we saw on the map earlier. And you can see that the error grows. So the correlation is lower. The correlation reduces when the forecast is longer. In the equatorial area, we have more errors in currents because we have biases which reduce the skill of the models, but still the model has some skill and is very useful. So all this information again on the product quality dashboard. Now just a word about the reanalysis and the capacity of the reanalysis, which is a long time series starting in 1993 to capture the trends, the long-term trends in the ocean. So here I'm illustrating this. This is the reanalysis here in the bottom panel, and you can see the sea level trend. So you have features here. You can see small features because it's quite good spatial resolution. So you can see the mean, the sea level rise, sorry, the signal of the sea level rise over the decades. And you can compare you can see that there's a very nice comparison with what we can get from the observations, from the satellite observations of altimetry on the top panel. So today, the reanalysis, they do not capture all the trends very well, but they have some skill. They can capture many things. And the ocean variability is quite well represented. And so Simona is going to talk about that later on. But what you have to know, the take-home message is that today these products have a lot of benefit. You can really use them for many applications, the near real-time products and the reanalysis products. They are validated using using standard validation procedures, and these validation results are available online. And we are working at the Global Monitoring and Forecasting Center to improve regularly these products. And the improvements which will come in 2022 and progressively are mostly model upgrades. So we're going to move to a new version of the model. We're going to improve the data assimilation of sea surface temperature. Also, the atmospheric forcing are improving in terms of resolution and quality. So we can expect nice improvements in terms of quality. So here, a recent paper too on the reanalysis from Lelouch et al. 2021. Which will give you more information on the reanalysis. Okay. So that's all for me. Thank you very much for listening to this presentation.
Thank you, Marie. Merci, Marie. Please stay on for the Q&A afterwards, because I'm sure there's some questions for you. Just a reminder to all participants, sorry, the Q&A on Zoom is not activated, but we're using Slido. So please put in your questions there, or in the discussion, we will note them down. Okay, so we'll move on to our next presentation by Coralie Perruche, who is an oceanographer specialized in biogeochemical products, and she'll be presenting the biogeochemical model. Coralie.
Hello, everyone. Do you see my screen?
Yes, we can see your screen and we can see you. So the floor is yours.
Perfect. Thank you. So hello, everyone. My name is Coralie Perruche, I'm working in Mercator Ocean International, and I will talk today about the global biogeochemical modeling products. That is to say, a reanalysis and an analysis and forecast system. And I wanted to underline first that the advantage of these modeling products is that they are 3D and continuous in space and time, and they provide many dynamically consistent variables. So here are the colleagues who are involved in the developments of the biogeochemical systems. We work on the model developments and implementation, both for the near real-time and the multi-year systems. We work also on the assimilation methodologies and on the whole validation process with many observations. Let me start with the biogeochemical model. For global configurations, we use the Pisces model. It is a model of intermediate complexity with 5 nutrients, 2 phytoplankton generic species, 2 zooplankton species, 3 compartments of detritus. In phytoplankton, we distinguish the content in carbon, in chlorophyll, in iron, and 4 diatoms in silicon. The ratios between carbon, nitrogen, phosphorus in phytoplankton and zooplankton cells are constant. And on these pictures, you have all the processes that are modeled in Pisces. For example, the nutrient uptake by phytoplankton, the nitrogen fixation, grazing, remineralization, and so on. And on top of that, you have the external supply of nutrients from rivers, from dust, iron from sediments, and from sea ice. Talking now about the global systems, we have 2 systems on the Marine Copernicus web portal. The near real-time one on the left and the multi-year product on the right. Both systems have common modules, and they are indeed operating the 3.6 version of NEMO-Pisces biogeochemical model on a global quarter-degree grid, and they are forced on an offline daily basis with the NEMO 3.1 physical model. But there are a few differences between the 2 systems. The near real-time system is a bit more complex. So first, it is forced by a higher resolution physical model. And there is a coarsening from 12 to quarter-degree grid. Second, there is data assimilation in the physical model. Third, there is a relaxation towards nutrient climatologies on a 1-year relaxation scale, allowing the biogeochemical model to develop its own seasonal and interannual variability. In fact, this is done to mitigate the impact of physical data assimilation that has been shown to generate an upward flux of nutrients and thus an overproduction in the tropics. And finally, the biogeochemical model is also constrained by the assimilation of ocean color surface data that allows to constrain the model in the mixed layer. The multi-year system is simpler. It is forced by a non-assimilative physical system and has no biogeochemical data assimilation component yet. In an effort of simplification, both systems provide daily and monthly fields of chlorophyll, carbon, phytoplankton biomass, nitrate, phosphate, silicate, iron, surface partial pressure of CO2, pH, primary production, and oxygen. And on top of that, The near real-time system provides 10 days of forecast. So some indications to get these products. You go on the Marine Copernicus catalog and you click on ocean products. Then you search for products 128 and 129. And here you have the small description of the product features. In the documentation tab, you have the quality information document that presents a thorough assessment of the product. So from now on, I will focus on the near real-time product by showing some plots of the validation procedure. Here, some basic validation of surface chlorophyll. We use here the global ocean color product of Copernicus to assess the climatological and large-scale chlorophyll distribution. On top panels, you have the surface chlorophyll with on the left the model and on the right the ocean color observations. You can see a good agreement between the model and the ocean color data. On the bottom, you have the root mean square difference on the left and the log bias on the right. And you see that the RMS difference is quite satisfying in a very large area in and around the oligotrophic gyres. It increases in the more productive regions in mid and high latitudes, which are more turbulent and less efficiently observed by ocean color sensors. Here, I show the quality evolution between the two last systems with a Taylor diagram. That kind of diagram allows us to synthesize basic statistic like correlation, RMSD, standard deviation on a single plot and to compare two simulations. In red, you have the previous system, and in green, you have the new one. So we consider here 4 quantities of interest. In square, you have the low chlorophyll in the top 100-meter layer. In circles, you have nitrate on this layer. And in triangles up and down, you have the oxygen at sea surface and at 300-meter depth. And the yellow star here is the reference data sets that the model should be as close as possible to. So this reference data set is the Biogeochemical Argo float database, and it is totally independent. And I have to say also that these statistics are computing globally and in 3D and over 3 years. And with the arrows, you see the clear improvement in quality between the last 2 versions. We also monitor the quality of the system along the trajectory of each biogeochemical Argo float. Here you have one example of a float that starts in the Antarctic circumpolar current and goes into the Agulhas current. The left panels are for the float observations, and the right ones are for the model. And on the top, you have the nitrate, and the bottom, the chlorophyll. And you see here that the model captures well the change, the progressive change of regime in nitrate. But it kind of fails at reproducing the levels of chlorophyll in the Antarctic circumpolar current. In fact, it is probably due to an inconsistency between the ocean color observations that we assimilate and the biogeochemical Argo datasets. but we have to investigate further this. So after the change of regime, you see that the model is able to catch the seasonal variability of chlorophyll in the mixed layer. To conclude, I would say that these modeling products are really interesting because they are 3D, they are continuous in space and time, and they provide many consistent variables. Moreover, they have a wide range of applications. They are first used to force higher trophic levels models, like the one on the Marine Copernicus web portal. You have an illustration here on the left with the mass concentration of epipelagic micronecton. Is the product MicroRIS, it's the product 133 that you can download on the Copernicus portal. Our biogeochemical model is also used to as boundary conditions for higher resolution regional models. Sorry, and they are used to do global indicators on pH, ocean carbon uptake, coral bleaching. And they are also used to do research, for example, to study the impact of marine heat waves on plankton ecosystems, or to study the impact of ENSO variability. So I'm done. Thank you for your attention, and I will be happy to answer your questions.
Thank you, Coralie, for that concise overview of the biogeochemical products. I invite you all to look on the Copernicus Marine website and look at these products. And if you have questions, please submit them via Slido. Hello to all of you who just joined. I saw a lot of people joining during this last presentation. Welcome. So now I'm going to give the floor to my co-moderator, Ergane, who will present the next two speakers, and we'll also do the Q&A session for this part. Let me just share my screen. Okay, Ergane.
Yes, okay. So we're now switching to the presentation of the two first observation products. And Chongyuan Mao is going to present us the first observation product, being the sea surface temperature. So Chongyuan is a senior ocean scientist at the Met Office, which is the UK's national weather service. Sorry. So hi, Chongyuan, can you share your screen?
Yep, sure.
Thank you.
Start everything. Sorry, I'm a bit slow on this one.
It's okay.
Hopefully you can all see the screen now. I just try to do the presentation. Okay. So good morning, everyone. I'm Chongyuan Mao. I'm an ocean scientist at the Met Office in the UK. Glad to join you today in the workshop. So, So today I'm going to talk to you about sea surface temperature and different types of SST and products with the focus on the Copernicus Marine Survey's global satellite SST products. So SST sounds quite straightforward, but actually when you look at the a figure which I include here is from the group for high resolution SST, it's not so simple. Depending on depths where the measurement came from, it could be skin SST, it could be subskin, it could be SST at a given depth or in the surface layer, or it could be foundation SST, which is the SST free from any diurnal variation. So because we have different kinds of SST and we also have different kinds of measurement, here you go. In the broader group, we have in situ observations, which is the instrument sitting in the ocean doing the measurement, or we can measure SST using remote sensing, which is satellite sensors. For the in-situ observations, I'm sure you're going to have talks to kind of look into that in more details, but generally you could have drifting buoys, moot buoys, ships or argos, and lots of more modern technologies these days. For satellites, there are infrared or microwave sensors, depending which wavelength the sensor is receiving signal. It could have polar orbiting or geostationary platform covering the whole globe, or just sitting on top of one region and looking at that day and night. To point out a few things, so because data represent different depths in the ocean, so when we compare different kinds of products, we need to take into account there could be biases between them. And also satellites, they don't actually measure SSTs directly, but instead it's retrieved from different algorithm. And in this process, you also introduce uncertainties and errors. So again, just caution when comparing different products. For satellite data, depending on the process level, how processed a product is, it can divide it into different levels. So level 2 is more or less the most basic SSD products that you could get. It's just essentially a pixel, comes with latitude, longitude in a 1D array or something. For L3 uncollated data, L3U, these pixels are put into kind of swaths, and you have the global sense where the swaths came from, but you typically have one swath or two for each file. And for L3 collated or super collated files, L3C or L3S, this time you have a global, roughly complete data set, but you can see here in the screen at the bottom left, there are still lots of gaps in between these swaths. And when we progress to L4 and it's completely global complete with no gaps, the gaps usually filled with the various different schemes for data simulation, etc. For Copernicus Marine Service data, we typically provide L3C and above, so there'll be global, collated, or complete gap-free. Today I'm going to focus on 6 of the kind of global products that we have, but just to point out, we also have regional products, say in Europe, like the Mediterranean, Black Sea, etc. They also have good products there if you're interested. The easiest way probably is to go to the Marine Survey's Ocean Products page here at the bottom left, and you can see a panel look like the one above. You can select different regions, different parameters or temporal coverage to narrow down your search and find the one that's useful for you. I'll go through these products sort of in slightly more details. The first one, I'll start from lower level to high level. The first one we can provide is L3S, is a global complete but with gaps. So it will be appeal to users who don't want anything to fill in the gaps, just data itself. So it is a foundation SSD with a resolution about 0.1 degrees. The next one I'm going to briefly touch on is the L3 ensemble dataset. It's also near real time, and for this one we basically collect various of L4 products and then produce an ensemble between them. The end result is a quarter degree resolution product. So this will be useful for people who are interested to know how different each L4 products are from each other between different providers. And also the products comes with the SSD gradient, so it'll be useful for anyone who wants to have a look at that. The next 2 products look very similar. They're all based on the Austia system, which is the ocean sea surface temperature and ice system we have in the Met Office. But the difference between the 2 is the top one is near real time, which means we provide a file a day, and the bottom one is reprocessed. So both of them are on 120 degree resolution and also foundation SSD. For the near real-time one, it was subject to changes day to day, say the data availability, or it could be the most noticeable change would be when we have system upgrades. So if you look at over time, then there will be some inconsistency in the near real-time data, but it will be useful for users who want to know how the products is date from, at the moment. If you want to update every day, then this would be the one that's very good for you. In terms of reprocess, the benefit would be it will be one consistent configuration all the way through. So from 1981 all the way to 2019, I believe there is more recent data being processed. So that will be useful for anyone who wants to have a consistent data set through historical periods that you can do your research on. One of the things to point out, for the near real-time products, we also have monthly and seasonal mean, and every day we also produce anomalies and bias files, but all of these are on quarter-degree resolution instead. And for both products, we also have in situ observations that have been used to generate these products. The next one is the skin ethnicity products. So we've been talking about so much of the foundation ethnicity in previous products, which is free from any variation due to daily changes like the solar flexes, etc. But now we actually kind of single out these bits which have been influenced by the diurnal changing, which will be appeal to users who are interested in the diurnal cycle in the top layer of the ocean. And these products are L4 and a quarter-degree resolution. And on the right-hand side, I've also include a figure basically showing you the distribution of the warm layer over 2 days periods, and the warm layer being the difference between the skin and the foundation SST. The next one is again reprocessed, but this time instead of being foundation SST, it's SST set as 20 centimeter depth. And this would be particularly useful for anyone who wants to do climate research. So this have the same resolution as the previous reprocessed data, as I mentioned, but do not to kind of mix the two. First is the depths where the SST is supposed to represent, and also this particular product is kind of funded by the European Space Agency Climate Change Initiative, and also the Copernicus Climate Change Services. So from these data sets, we also generate ocean monitoring indicators, which are also available from the Copernicus Marine Service website, which are linked here. These indicators include annual anomalies, a time series global coverage, average SST anomaly, and also a map of trends in SST, which shows an example on the right-hand side. As you can see, this is a trend between 1993 and 2019, and you can see the north has warmed a lot, and then the south less so, and there was hotspots of the warming in the global domain. And also there was a couple of pockets where cooling actually occurred. Anyway, so there's a lots of information you could can exploit from all these products. This is one example. Oh no, sorry. Here we go. Just to summarize, in this talk, I sort of briefly talk through 6 of the global satellite-based products included in the Copernicus Marine Service. And also just to point out, there's also European regional products available. So all these data files, they are in the common NetCDF data with the format specified by the group for high resolution SST. And all these products are have different uses. So we have L3S data or L4. And we have SST products at different, from representing different depths in the oceans, the foundation, skin, or 20 centimeter depths. We also have near real time or consistently reprocessed data to suit the different uses of the users. And we also provide ocean monitoring indicators that could be useful for some users. That's everything from me. Thank you.
Thank you very much, Sandrine. Please stay with us because I've seen in the chat that you have lots of questions about your presentations.
Sure. Thank you.
And so we're now giving the floor to our second lecture. We're going to have Antoine Mangin, who is the scientific director of ACRI-ST, which is a company specialized in space sciences, and he's going to present us the ocean color observation products. Hi, Antoine. Thank you for being here.
Hello, everybody. Can you see my screen?
Yes.
Good. So welcome everybody to this webinar. So as just been said, I am Antoine Mangin, working in a company in France. I am an oceanographer and I'm using a lot of ocean color data. So the ocean color terminology is a little magic because when you ask somebody what is the color of the ocean, of course, these people will tell you that the ocean is blue, usually. And in fact, we are measuring the coloration of the ocean and making profits of the difference of contrast between several colors, let's say. So if the ocean is a little green, then we do the ratio between the lights coming from the blue to the light coming from the green, and then you get an information about the chlorophyll concentration of the upper layer of the ocean. So this is, chlorophyll is very useful for many things, marine biology, of course, but also is a synonym of the carbon pump to the ocean. You might know that the ocean is equivalent to the land vegetation for what concerns the balance of carbon in the atmosphere. Okay, and if we are looking for more brownish, reddish colors, we can characterize what we call the suspended particulate matter. So we have a kind of proxy of the turbidity of the water. So again, doing the ratio, more or less, doing the ratio between the brown colors and the red colors and the blue. If we are looking for yellow colors, then we can access to some organic matters, what we call the color dissolved organic matter. So we have concentration of organic matter at the sea surface, either linked to the chlorophyll or linked to human and anthropic activities. So you have generally a lot of sebum on the estuary. And lastly, what is really important as well is algal bloom. So you might see here we have three colored algal bloom. One is red, the other one is green, the last one is white. So that are known as red tides or green tides. And this has a significant impact on fishery and especially on aquaculture. Because when you are doing aquaculture, it is done in fixed location, fixed cages, and if you have an occurrence of algal bloom, then you get in trouble with this. And the white one is a Coccolito forwarded bloom, which has no harmful impact. Okay, so just in few words, what we are measuring is the coloration of the sea. So you have to remember that it is optical sensors, so optical and near-infrared sensors. So we are impacted by the atmosphere and also by the clouds in the atmosphere. So that's why I drew this. So we receive the optical flux from the sea, but also from atmosphere, plus perturbation, plus clouds, etc. So we have to do a cleaning.
Excuse me, Antoine, could you please set your microphone because we have a little difficulties to hear you?
Yeah, can you, how can I, no, is it okay now or no?
I think it's better.
It's better. Sorry. I don't know how to. I will try to speak louder. Is it okay like this?
I think so.
Okay, so I will speak louder. Sorry for that. Okay, so after some arithmetics from the signal we get on the satellite, then we access to the marine normalized water living reflectance. Okay, so the signal which is only coming from the sea, and here we can access to some optical properties, the ones that are listed in pink, and we can access to green, well, more biology information about the sea surface. So the pink is optical and the green is related to the marine biology. So here I'm going to some examples. So I invite you to use the MyOcean viewer. So you just have to Google a MyOcean viewer and you will get access to this. This is a very powerful tool, in fact, that allows you to display all the products that are available, but also to get information at a given point or to do some transect or some time series of parameters. Very useful, very well done and useful. So this is the chlorophyll concentration for 1 day in the year. And here you recognize here offshore Morocco and Mauritania, etc. In Senegal, you recognize one of the large marine ecosystems, which is the Canarian upwelling. But also in the south, you have equivalent, which is the Benguela upwelling. And these two areas are known to be very productive for doing a lot of fish recruitment there. With the tool, you can access to temporal information. So you see here 3 locations of the Canarian ecosystem, a large marine ecosystem. And you see the seasonality of here, of this. Here, offshore Mauritania, you know that the upwelling is permanent, and more in the north, you see that it is a seasonal upwelling. What is very important for this is that for each product, well, more or less each product in the catalog related to ocean color, you have an uncertainty which is attached to the product. So for the product we just displayed, here you can have access to the uncertainty of the chlorophyll concentration. So you can see that in these very productive areas, the error is around 5%, which is very good results. Unfortunately, the error is less important when you have real information. But you see here in the Gulf of Guinea, here you see that it goes up to 25% of uncertainty because mainly of cloud coverage. So this is for marine biology. Another parameter which is very important is the biomass. Okay, so here you have an estimate of the primary production for 1 day. You also have it for months or for years. So you see again the very productive areas. Here, if you're doing marine biology, you might be interested in having diatoms concentration or other what we call PFT. So it's a phytoplankton functional type. So I have the translator. So in French, it's des groupes fonctionnels de phytoplankton. So you have this diatom. So diatom here we are in Benguela, so the system, a very productive system. So you have big phytoplankton. And here you have also access to phytoplankton, which is a very, very small phytoplankton, but more at the beginning of the food web here. So you can do the difference between the big particle and the small particles if you are doing some study about the recruitment and fish recruitment. But also you have this information. So for the PFT, you have the diatom, the dinophyte, aptophyte, green algae, prokaryote and prochlorococcus. If you are doing some ecological model, it's very useful. And also you have the size distribution, an estimate of the size distribution of the phytoplankton. so pico, nano, and micro. Well, here is a transparency, so you will see only, well, you see that we are looking at clouds. We have some disturbance linked to clouds, but overall we have information about the transparency, which is given by the Secchi disk depths. Okay, I'm sure you know this. So here it is in the Gulf of Guinea, and this is very important for the marine biology because you need light to penetrate in the water to do some biology, but also you need a warm heat transfer in the upper surface to do physical process. So transparency is a key parameter. Here it's a zoom on Tunisia. I don't know if there are Tunisians in the room today. Here it's very well known. It's a Gabes Gulf, which is was considered as a nursery in the Mediterranean. And here we see the transparency. And here is there's a meadows of Posidonia. Posidonia is an algae. And there is an extension of this Posidonia in this area, and it is probably due to the evolution of the transparency that will kill part of the Posidonia. And here you have another proxy for transparency, which is given by the KD, which is a diffuse attenuation coefficient. Okay, so just to summarize, this is the availability of the product. So at European scale, you have ocean color products at 1 kilometer resolution. So in the Mediterranean, so for North African people, it's okay to have something at 1 kilometer, but also now we have 100 meters and 300 meters for all coasts in Europe on a daily, monthly, and annual time step or integration time. For other parts of the world, we have a 4 kilometer resolution plus this 300 meters chlorophyll information resolution. So that's quite good. Again, with daily, monthly, and annual time step. We have all the products is available from 1997. So you have consistent time series that allows you to do some kind of seasonal classification and also to try to go to climate evolution or trends. You have uncertainty estimate for most of the products, so that's very valuable. And I invite you to have a look to this because it's important to take it into account. And for all of these products, you can report to the documentation, which is a heavy documentation, I have to say, but it is useful and it's very complete. So either the quality reporting or the product user manual. If you go to the catalog online, so here you see you have to go to global ocean for not what is northern Africa. And you see the marine biologies under plankton and primary production here, the green one. And all what is optical is under the pink one, so reflectance, transparency, and turbidity. So it's really easy to get the data from here. And that's it for me. Thank you very much. And sorry for the sound, which was not so good.
Thank you very much, Antoine, for this very interesting presentation. So we will now ask the lecturers to stay with us because we will need their help for the Q&A session. Maybe, Roman, you can share your screen with the questions. Okay, yeah. So we will begin with the first questions. The first question, the ones that got the most votes. So the first one is, how much in situ data from Africa is being used to validate these products? How much data do you require to validate these products to ensure accuracy? And are you in need of more data in the African region to better the products for these regions? Maybe Marie and Coralie, you want to answer this question?
Yes, thank you. Maybe I can start and Coralie can complement. But of course, we are using a lot of in situ data from Africa, but mostly what is sent to the global assembly centers. So everything that is sent to the GTS or to the global assembly centers for in situ observations, such as the in situ thematic assembly center of Copernicus, we will use for data assimilation and for validation. For validation, we can use, well, something to know is that the data assimilation subsamples the in situ data. We don't use, for instance, very high frequency in situ moorings. We only use part of this information because of the model, the representativity of the model. So for instance, when we do the validation, we can use the full time series of the mooring, for instance, to do validation afterwards. So it's going to be very useful to have these observations. And if you have some and you want to share, I would really encourage you to do so, because it's going to be very helpful to improve the quality and improve the validation, the information and the accuracy for sure. Maybe I can leave the floor to Antoine. I see that you want to add something.
Yes, thank you. Thank you, Marie. Just to say that, yes, of course, we are using in situ data, but if you have more in situ data, we are more than happy to access to this data. The point for the ocean color is that when we are very close to the coast, we need a lot of data because we depend on a number of parameters, and the chlorophyll is rather difficult to extract. So if it is offshore, we have plenty of measurements coming from BGC Argo, for instance, or all the floats. But when we are close to the coast, yes, we are using data, but yes, we are collecting data, and we need data always to improve the algorithms. I remove my hand.
Okay. So Coralie, do you want to add something, or are we done with this question?
No, I think the answers were very complete.
Okay, great. So we can switch to the next question. Do you use HFR radar network for global current monitoring? Marie, maybe?
Yes, I can answer. At the moment, we are using, yes, we are using HF radars for global current validation. We are using European radars from Copernicus Marine Service, and also other radars all around the world, which are available for free and we can get through the databases. And it's very useful, but very costly. But still, we keep comparing with this data, but it's not always easy to compare the physical signal from these radars with the physical signal from the model, because it's sometimes different. But it's, yes, very valuable information, and that we wish to publish on a regular basis in the future.
Okay, thank you for this answer. So we're going to have two more questions, but we won't have time to go through all the questions, but we will give you the answer in a shared file. So all the questions will be answered. So the next question is how to link the global model to a smaller regional model. Again, Marie and Coralie, maybe you want to answer.
Of course, I can try to answer. This is not what I'm doing every day, but what I can say is that you can have, well, today you can have access to 3D model outputs for any area of the globe, because the global products at high resolution will give you this opportunity to have boundary conditions in any place. Now, the temporal frequency is daily today and hourly at the surface. So there are many things that you can do starting from that, but in the future, the time frequency of the output is going to be improved. So, there are always possibility to contact directly the Marine Service or Mercator Ocean, so that we help you with building a regional configuration and how to use our products at the frontiers of your domain. And also something good to know is that the Marine Service is going to work on this, on implementing solutions for coastal or regional models to use the products and build their configuration. So this is something that is going to be an evolution in the future for the Copernicus Marine Service.
Okay, great. Thank you for this answer. And so I think the next question will also be for you. What is the NEMO model surface layer thickness?
It is 1 meter near the surface. So there is one vertical level every meter until 22 meters depth, I think. So it's quite nice to be able to have accurate surface currents. It's a good vertical resolution for a global model.
Okay, thank you. So this is the last question that we are going to answer in this Q&A session, because we are late and there are plenty of questions. But again, we will share you a file with all the answers. So don't worry, you will get your answers. So we will now have a 5-minute break. It was supposed to be 10 minutes, but because we're late, we will just have 5 minutes. And so we will be back at 11:05 CET, if it's okay. In the meantime, you can have a look at the Padlet and you can pin your location so that we know where you come from.
Ergane, sorry. Simona speaking. Can you hear me?
I can hear you.
Yeah.
Okay.
Simona?
Can I try to share the screen to see if everything is working fine? Because I'm sorry I didn't have time before.
Okay, go ahead.
Ergane est là, on est en ligne encore.
Ergane, je pense qu'elle fait une petite pause.
D'accord, parce que on répond aux questions.
Pardon, je suis là, mais j'ai coupé mon micro.
D'accord.
J'étais muté. Les questions, on répond, enfin, comment ça se passe pour les questions? On récupère les questions, on essaie d'y répondre ou...
Peut-être Lillian et Fabrice, vous pouvez répondre?
Oui, on va récupérer toutes les questions et après on va venir vers vous pour répondre. Voilà, merci.
Parfait, merci.
Simona, je pense, c'est bon, non?
Yeah,
Okay.
Can you see it?
Yes,
Yeah.
we can see it. Okay.
It takes a while at the beginning, to put it in full screen, but
Okay. No, but
working.
it's fine. Okay,
Okay,
I'm just
thank
going to go back to the break slide.
Yeah, sure.
Okay. So welcome back, everybody. We are going to resume with part 2 of the workshop. So next up, we have Paz Rottlan Garcia, who is a trainer and front-end developer from the Balearic Islands Coastal Observing and Forecasting System, SOCIB, and she'll be presenting in situ observation products. Paz?
Morning.
Good morning.
I think I have to share the screen, but
yes.
I'm not
Oh,
allowed.
yes. I need to stop sharing my
Okay.
screen. Now you should be able to.
Okay.
Thank you.
Let me know when you see it.
Yes, we see it. Yeah, perfect. If you
It's
can
on
make
presentation mode or
no, it's not.
Okay.
Yep.
Let me check. Here. It's okay now?
Yes, perfect. Thank you.
Okay, thank you very much. Well, thank you for joining this 10-minute talk about in situ observations. I'm Perruche Garcia, and I'm here on behalf of Sylvie Poulequin, who is the actual manager of the group in charge of procuring this kind of observations in the Copernicus Marine Service, which is called the In Situ Thematic Assembly Center, or the In Situ TAC, in case you heard this term onwards. The first thing I would like to clarify, so we are all on the same page, is what we mean when we talk about in situ observations. And the in situ observations are the data reported by a wide range of platforms, like the ones you can see on the slide, that are directly deployed on the ocean with the objective of measuring certain variables like temperature, salinity, and so on. This means that they are quite different from the other kind of observation that you find in the catalog, which are the remote satellite observations. Okay, in this case, we are talking about on-site measurements. The implication of this approach are three main ones that I wanted to share with you. The first one are that the resulting products have gaps because we only have data where we have a platform reporting data from. Also that the resulting products doesn't have an homogeneous resolution because in the end, the operator of the platform set the sampling interval, a certain sampling interval, and this can vary a lot from platform to platform. And the third thing is that the resulting products contains more than one data type. Okay, so you will find time series, but also profile-like data and also gridded data, depending on the source that reported the data. One, as I have said this, well, I wanted to share with you also the purpose of providing this data in the Copernicus Marine Service catalog. And the purpose is for improve, obviously, the other products in the catalog, the ocean model products and also the satellite products through simulation and validation tasks. Okay, also, if you are in your institute involved in this kind of task, I would like to also invite you to use these in situ products for it. The main three workflows of the group procuring this kind of data is the near real-time products, which is the first one that you see on the top. The delay time products delivery, and also some other cross-cutting activities. Regarding the delivery of data in the near real time for the Copernicus Marine Service catalog, I wanted to highlight three main steps. The first one is the strong collaboration with international organizations like CDataNet and Edmonet, with the objective of providing the most complete set of data. And also that we apply quality controls, real-time quality controls over the data. And we, of course, focus on deliver and standardized NetTF format for users. Regarding the delivery of reprocessed products in the catalog, the main focus in this case is not to deliver data as soon as possible, but to deliver the highest quality of data as possible. Okay, this will be the objective of the reprocessed products. And of course, this is the ideal product to use for validation tasks. Okay, and the core is to perform periodic scientific assessment over the observations delivered as reprocessed products. Then we have several other cross-cutting activities, like obviously documenting all these processes. We also contribute to the scientific exploitation of this data through the Ocean State report that I think was presented to you on day one of this workshop. And we also procure a dedicated website with a lot of more information about the work that is done regarding the integration of in situ observation in the Copernicus Marine Service. And I will show you later some snapshots of this website. And of course, the main output of these workflows are the reprocessed products and the near real-time products. And in here in this table, you can see the difference, the main difference between those kind of products. The first one is the update rate for the reprocessed product. This is updated only once every 6 months. And in the near real-time products, the information, the data inside is updated hourly. Then the scope for the reprocessed product, we are only delivering global products, while in case of the near real-time product, you can find regional products and also global products. And regarding the quality mode, for the reprocessed product, we are only applying delay mode quality control, while in the near real-time, you can find a mix of quality controls in near real-time through automatic test, but also in delay mode through scientific assessment. And then regarding topic, obviously for the reprocessed product, we have a bunch of experts checking the data, and these are experts of a certain parameter category. So we have dedicated products for example, currents, carbon, waves, biogeochemical products, and so on, as you can see on the list below. Nevertheless, for the near real-time data, the situation used to be the opposite one. We have most products dedicated to a wide range of parameters, the multi-parameter products, although we can also we are also providing dedicated products like the carbon and the UV that you can see listed below. This is the overall evolution of the parameters included in the different products. I'm not going to talk about all of this because we are short in time, but I would like to mention, for example, the last events that happened in 2021. The first one was the inclusion of the Argo currents in the reprocessed UV product. Argo derived currents, sorry, in the reprocessed UV product, and the inclusion of Monet chemistry data in the in situ near real-time products. These two events happened in the last year, for example. In this table, I try to summarize the way the access services that you have available for accessing this kind of data. Of course, the FTP service is the main one. This is the one that is currently guaranteed the access to the full data set. You can access it through the NRT FTP server or through the multi-year FTP server. This last one is the one hosting the reprocessed product that I mentioned before. And then you have other two services, the ERDAP services and the WMS services that are available only for certain products, okay? It's not for all of them. For example, in the training material, we will focus, for example, in using the ERDAP service, which is quite friendly. And here you have the snapshot of the website I told you about. I just modified one of the slides, for example, so that you can see where you have to go to if you want to push data to the Copernicus Marine Service in case you have in situ data around the Africa region. Basically, you have to go to marineinsitu.eu, and in the submit data section, you will find some emails to contact to in order to push your data. Okay, I just highlighted the ones that are important for your region. In case you are facing the Mediterranean Sea, it would be the third one highlighted, and in case you are in any other area, you have just to contact the first email listed. Okay, and then you have, of course, all the documentation produced. and also some metrics that highlight the content of the different products produced in terms of number of platforms and quality of the observations and so on. And of course, a friendly viewer, okay, that is called the dashboard. Well, that's all. The last step is to be able to provide feedback to the providers, the ones that are actually to be acknowledged for gathering the data. And we are about to release in the website that I showed you just before a section for doing so, maybe late in this December or next month in January. And just if you are going to go and try the training material that we provided, we will use the ERGA service to discover, download, and plotting some of the in situ data available in the Copernicus Marine Service. And that was all. Thank you very much.
Thank you, Paz, for your presentation on valuable in situ observations. Could you maybe put in the links, some of the links you shared in the discussion in the chat?
Of course, yes.
Thank you. Thank you. Okay, next up we have Vinca Rosmorduc from CLS, who is an oceanographer specialized in altimetry. Vinca, welcome. Thanks for being here today. You can share your screen. Go ahead.
Yeah, welcome to everybody, and thank you for attending. You hear me well?
Yes. It's breaking a little bit.
Screen?
We can see your screen. Yes. Yes, we can see your screen.
Okay. So I'm going to talk to you about sea level and satellite altimetry, explaining a little bit which parameters are in the product distributed by the Marine Copernicus service, and which are the product and how to access them in the catalog. And then in the end, I will show you a few examples of what you can do with those products. So sea level and satellite altimetry. Satellite altimetry is a technique.
Sorry, Vinca, sorry to interrupt you.
Yeah.
Can you go into presentation mode? Because we're not seeing the slides change.
Okay, but
Please.
I am in presentation mode.
Maybe you're on a different screen. I'm not sure. Because we we have one screen. If you if you click on the little icon at the bottom, you did something, it switched and then it went back.
Okay. Yeah.
No, still not.
No.
Well, okay, go ahead.
That was what I had.
If you just click on the icon at the bottom, there's the
that's what I did.
Yeah, but yeah.
Exactly.
Well, don't worry. If it's not working, it's not working. Okay. Just continue. Don't worry.
Okay, so satellite altimetry is a technique. It's on board a satellite, you've got a sensor called an altimeter. It's on board several satellites, not only one. The altimeter is a radar which measures the sea surface height at the surface of the ocean with respect to a reference level. Well, in fact, the satellite is measuring on one side this distance between itself and the surface, and using other instruments, the exact altitude. So we are making then a difference between the satellite to surface distance and the altitude, and that is what we call the sea surface height with respect to the ellipsoid. And what we are distributing are the absolute dynamic topography, which is the dynamic height with respect to the geoid level, and also the sea level anomalies, which are the variation of the sea level. So for that, we're subtracting the altitude minus the distance between the satellite and the surface, and we've got a bunch of different corrections. You've got the tides, you've got the atmospheric pressure, and a range of different correction. I'm mentioning it because in some of the product you'll find some of the correction for you to uncorrect and change using your own correction. The typical idea is for tides, because you can have a better tide model than we have for your region. One of the major points is that altimetry is not imagery for now, because in 1 year we hope to have a satellite which will do imagery, but altimetry data for now are measured along a narrow thread just beneath the satellite. So it leads to maps like the one which is on the screen.
Sorry, Vinca, we're still on the first slide. There's no, it's not going.
Oh,
yeah. Yeah, now we can see it. Thank you. Now we can see it.
So
Okay.
I don't know what's happening.
Well, we can see now the map.
Okay, sorry, because that was what I was explaining.
Yeah, there was something
with distance and satellites. It's easier to understand with the scheme. Sorry, should have told me earlier.
Sorry about that.
The maps are like this natively. And we are making some interpolation processes using as many satellites as possible. So we've got 6 of them just now. And using the physics of the ocean, what happened before, and if we are not in real time, what happened after, to make grids of the data. So the products we are distributing are the sea surface height anomalies or sea level anomalies, which show you the variability of the ocean with respect to several year mean. We are deriving geostrophic currents velocities from those heights. We also have the absolute height, which is the sea surface height with respect to the geoid. A lot of people are calling it sea surface height, but you'd better mention a reference. Otherwise, you don't know what is the zero of your data. So this is showing you whatever is moving in the ocean. So you've got the main stable currents and the variabilities both. And we also have derived the currents from those surface slopes. So with those currents derived from the absolute height, you've got the mean currents flow and its variability. Then we've got 2 different categories of products. We've got the gridded, which are interpolating between the satellites measurements. And we've got the along track data. The first one are the easiest to use. You can use them for mesoscale activities, the EDIS monitoring, the geostrophic currents derived application too. The along track sea level products are recommended for assimilation in numerical models, since the models are doing their own interpolations and processes like this. And they're also enabling you to change some of the correction, like the tides, if the global model we are using does not fit your need. To find those products in the Marine Copernicus Service catalog, the easiest is to click on the Ocean Products button, then use the search box to search for sea level without space, and then you'll have only the satellite measurement. If you search for the still C-surface parameter using the parameter search, you'll have also the model, which are good, but if you want the observation, this is the quickest way. We also have a product in the ocean monitor indicators, especially you've got the mean sea level monitoring. This is the list of products you'll have today if you're looking at the catalog. So you see the L3 are the along track data, the L4 are the grids, REP are the delayed mode data. We've got data since January 93 up to today in the near real time, up to about 6 or 9 months ago for the REP data. You've got the global and European area with Mediterranean Sea, the Black Sea, and the Northeast Atlantic in the area. And the indicators, the ocean monitoring indicators, are also depending on some predefined areas. So in about 1 week, you'll have quite some changes in the product. So you've got a major release in mid-December, where there are some naming scheme difference, and you also have improvements in the data, in the correction, and in other fields provided. You've got also a new reference surface, the mean dynamic topography, improved mapping, and new variables and some changes in the variable names. So don't be surprised. But if you need to use a long time series, I recommend maybe you wait for 1 week before using the new release for the reprocessed data. So now a few examples of what you can do with those data. So you've got oil spill dispersion. Here you've got deep water horizon oil spill 10 years ago, and the geostrophic currents and sea surface temperature beneath. So you see the oil spill deformed with a very good correlation with the geostrophic currents features. So that can be a way of using those data. We can also look at storm surges, removing the tide data to take it aside, because in a storm surge, the tide is of major importance, of course. So here you see an example over the Venice area. This is Aqua Alta of Venice, and in 19 you had a major Aqua Alta, which was seen with Sentinel-3A, which is one of the satellites we are using. At high tide, I think it was something like 1.80 meters or something. One of the major applications is also the assimilation in numerical models, like for weather forecasting. The altimetry is some of the reference that is used to fit the model as close as possible to reality day by day. And you can also have some example with the animal behavior. So I'm afraid I won't be able to show you this nice animation with these little turtles that you're seeing going around those eddies. The red dots are high eddies and the blue areas are lower than average areas. And these little turtles here is going around those eddies, and you see it's going faster because the currents are faster at the fringe of those eddies. So you can also study the animal's behavior with respect to the physics of the ocean using altimetry and sea level data. Thank you.
Thank you, Vinca, for your interesting presentation and your concrete examples. Please stay with us for the Q&A. Ergane, I'll give the floor back to you.
Okay, thank you. So we're going to have our two last presentations about the model products. So I will now give the floor to Alice Dalphinet, who is going to present us the wave model. Hi, Alice, you can share your screen now.
Hi, everybody. You see my screen?
Yes.
Yes, so I am Alice Dalphinet. I work in the wave team of the Copernicus Marine Service, and I will show you the wave product that we are developing with the other members of the wave team. So we are producing every day wave parameters from our global wave model, which is called MF1. We are producing 17 parameters of the total sea and the wind waves and the swells. Our model is running up to 10 days forecast, and we are using as forcing the winds of ECMWF and the surface currents field of the global model. You can find 2 years of archive in the Copernicus Marine Service, and the resolution of the parameters is in a 112 degree grid. So it's very important to know that we are assimilating data in our wave model. We are today we are assimilating 6 altimeters, and you can find if you are interested, you can find the observation data in Copernicus service in the wave TAC. In the map here, you can find what is the daily coverage. It is the coverage of 24 hours, and the 6 altimeters permits to have a very good spatial coverage. And we are also assimilating wave spectra from 3 satellites. It permits to correct period and also wave height. The last satellite that we have added to the assimilation is a CFOSat. It represents it gives the wave height and also the wave spectra. We have studied its impact in the wave model, and for instance, in the cyclonic season in the Indian Ocean, and we have seen that it can have an impact of more than 50 centimeters in the wave height. And we have also validated, thanks to independent observations, the impact of the assimilation. And here in this graphic, you see that it has a very good impact for high waves of more than 4 meters. So this assimilation is very important for us, and it permits to have a very good representation of the swell, particularly of the swell. And I want also to insist on the forcing by the surface currents. It is a daily field. We are forcing by the daily surface currents. So we don't represent the effect of tides, for instance, but we represent very well the strong currents and the effect of the strong currents in the wave field. For instance, here in for the Agulhas currents, I show here an example. we have the wave height at left, and the surface currents of the global model at right. And you can recognize the pattern of the surface currents in the wave fields because it alters the wave height, and it has also an impact on the wave period. So when there is a current of more than 0.5 meter per second, the impact on the wave height will be significant. We have validated the wave products thanks to independent observation. Here it's the observation of an altimeter. We've seen that we have a very precise wave fields in deep ocean with a relative error between 5 and 10%, and in near shore in Mediterranean Sea or near in Indian Ocean, we have an error between 10 and 15%, which is also very correct. We have validated also the products thanks to buoy data that you can find in the in situ TAC. It validates the model more in coastal area. So for a global model, it's not where it is expected to be the best suited, but we have very good scores with an error in a wave height of 14% and in the period of 11%. So it's very good for a global model. I'll illustrate the use of the wave model with a flooding case that occurs 7th of November in Ghana. The flooding was due to the tide also, not only the waves. So I show here only the wave part. There has been a swell coming from south with quite strong swell of almost 2 meters. At the right, you can find the analysis of the wave model. You have the significant wave height here, and you have something like 1.6 meters of swell, and the period of the swell is at right, and it reached 15 seconds. And you can see that 4 days before, the period was underestimated, but the wave height was well forecasted with also 1.6 meters. So this case illustrates the good quality of swell in the model. And the second products for waves is Reanalysis. Since last year, the wave Reanalysis is available on the Copernicus Marine Service. Its name is Waveris. It is very like the NRT model. We use also MF1. We are forcing by 3 hours wind of era 5 and the surface currents field of glories. And we are assimilating all altimeters available in this period from 1993 to 2020. And this the difference is that we are running Waveris or MF1 at a coarser resolution of 0.2 degrees, 20 kilometers in average. So it's very interesting to produce a climatology. It's possible to produce a climatologic field, like here in this example, or also wave roses.
Alice, we can't hear
That
you.
can be annual or you cannot hear me?
We missed, I think, about 30 seconds.
Okay, maybe I can stop the video. Only video.
Okay, yeah, stop your video. Thank you.
Yes, it's better now.
Yes.
Yes, continue.
Okay, yes, we have also verified that the Waveris is well suited for wave extreme. We have, for instance, in this case, we have confronted it against a buoy observation in the Austral Ocean, and we have seen that it is well correlated with the buoy. So the last ongoing developments for the wave model, we have this year we have added the assimilation of CFOSAT, and we have in December, so now very soon we are going to refresh the forecast twice a day, and in the near future we want to produce a regular scores against observation, and also add the forcing of wave parameters into the physical oxygen model. For the reanalysis, you can refer to this article, which gives more information on waveries. And for the next year, we have a big task with a new version of waveries. We are going to run it at 1/10 degrees. So it would be a better spatial resolution with a better bathymetry and spectral resolution also. And there will also be an automatic update of Reanalysis. So thank you for your attention. And if you have any question.
Thank you very much, Alice. Before giving the floor to the next lecturer, I'd like to remind you that we have the Slido where you can ask your questions to the data experts. And so we'll have the Q&A session just after. The link to the Slido is in the chat. And so I will now give the floor to Simona Masina, who works in ocean modeling and data assimilation. So hi, Simona, thank you for being here. You can share your screen.
Yes, good morning to everybody. Thanks. I'm trying to share the screen, but I get a message. Let's see if now it's working. Probably the previous one was still sharing. Okay, now it's working. Well, hopefully. Let me know if you, first of all, if you can hear me well.
Yes, we can.
Okay, and hopefully the full screen mode will come soon. Okay, so here it is. I hope you can see. Okay, my name is Simona Masina. I'm a senior scientist, an oceanographer at the Euro-Mediterranean Center on Climate Change. That is an Italian foundation, and today, well, I'm very happy and honored to be here to present.
Okay, sorry, Simona, but we can only see part of your screen. I don't know how you can fix this. Oh, yes, that's better? Much better. Yes, okay. Much better. Thank you.
Okay. Sorry about that. Anyway, yeah, I'm happy to be here to present a product, another product of the Copernicus Marine Service, that is the Global Ocean Ensemble Physics Reanalysis. This is really a joint and a coordinated effort among different institutions, in particular 4 institutions, the CMCC, where I'm working, the Mercator Ocean, the UK Met Office, and the ECMWF. So we heard the word reanalysis several times this morning. I would like just in short to recap what is a reanalysis. Well, basically the concept of reanalysis, as I guess most of you know, started to develop first in the 80s among the atmospheric community. And since then, most of the numerical weather and prediction systems are dedicated to provide global and regional atmospheric reanalysis. So following that experience, also the oceanographic community started to develop reanalysis, and nowadays most of the institutes that are here represented, especially the 4 that I just mentioned, are dedicated to produce and deliver ocean reanalysis. Here in this slide, very briefly, I try to summarize what are the ingredients, the main ingredients of ocean reanalysis. First of all, we need the data. We need all the data that we heard already this morning, in situ data, especially I would say the Argo networking observations that became available since the beginning of this century. We need altimeter data that has this incredible facility to provide a vision of the surface of the ocean at quite high resolution. So we need data, but we need other two ingredients, an ocean model and an assimilation scheme. It's really the assimilation scheme that is available nowadays in the broad range of variety, from the simplest one, just simple optimal interpolation, to variational assimilation scheme, and to the most complex ensemble Kalman filter scheme. Are these assimilation schemes that really merge together what is our virtual representation of the ocean that is given by an ocean model with all the ocean observations in situ and satellite data that are available. So this framework, this statistical framework, the data assimilation scheme, really provides what is our best knowledge and dynamical based knowledge of the ocean. So basically this is a reanalysis. In short, we can say that reanalysis are so created by a frozen system, so a frozen model. We don't change the model, we don't change the assimilation scheme while we are running the reanalysis, and we keep ingesting into this engine, into this scheme, all the observation, all the in situ and satellite observations that we have available. The goal, the final goal, is to provide the most coherent and consistent state of the ocean throughout all the period that we wanted to analyze. Saying that, the Copernicus Marine Service is providing not only global reanalysis, but is providing regional reanalysis for all the regional seas that are part of the Copernicus Marine Service. But here I will present the global ones, and specifically a set of global reanalysis. Because, well, we said that we have this magic framework with model, data simulation system, observations that provide the best knowledge of the past state of the ocean. But of course, each reanalysis, each realization is affected by many errors. So it's not the truth, it's not the complete truth. What you can also download easily, download from the server, from the Copernicus Marine servers, are two data sets, are two products in particular. One at a coarse resolution, it's basically 1 by 1 degree resolution, so 100 kilometers approximately of horizontal resolution, provided as monthly means. And another one that is coming from the same reanalysis, but is provided, at higher resolution, 25 kilometers by 25, and it provides, in addition to monthly means, also daily means. And for these two data sets, you can download three-dimensional temperature, salinity, currents, and two-dimensional sea level and mixed layer depth. All the information and details, as already said by the previous speakers, are provided in a very detailed documentations that you can also download. So as I said, each reanalysis is not the truth, okay? So how these products are built using an approach that is called an ensemble approach, and that tries to provide what is our best knowledge of the past, but also what is the errors that is affecting this knowledge. For example, here you have different realization. All the colors represent one single reanalysis, okay? So for example, one reanalysis coming from Mercator Ocean, another one coming from my institute, the other one from ICNWF, and the other one from UK Met Office. And you see they are different, of course. What you can do the average. You can calculate the ensemble mean among all these reanalyses and provide the ensemble mean, but you can also estimate the uncertainties that are affecting, that is affecting this product. And this is what we call the ensemble spread. So what, when you download, when you're looking for these products, sorry, I'm too sensitive, I'm touching. When you download these products, you don't only download the temperature and salinity, the currents and so on, but you also can download the uncertainties of each of these variables. This is just an example of, if you want to see, this is, for example, the potential temperature at a specific depth. In this case is half a meter depth for a specific month. This is the variable, so the temperature. The ensemble mean of this product, but you can also download, as I said, the spread, the uncertainties that is affecting all these variables. Here it means that when you have blue colors, it means that the uncertainties of this ensemble of reanalysis is very low. So all the reanalyses really agree with each other. They are coherent and consistent with each other. Where you start to see colors from yellow to reddish, it means that the reanalysis somehow disagree with each other. So the uncertainties of your product is larger, okay? And this, not very logically, I mean, it happens in the regions of the ocean where you have a lot of mesoscale activities like the Gulf Stream region, the Kuroshio regions, and the Antarctic circumpolar region. So, how can we use an ensemble of ocean reanalysis? One of the most interesting use and application is to calculate what we call in the Copernicus Marine Service ocean monitoring indicators, the OMIs. You can look at the web page and found a lot of these ocean monitoring indicators with the goal, they have really the goal, these are key variables with the goal to track the evolution of the variability in time of the ocean. Here, just an example of the ocean heat content, and you can download, trends at global scale, global average, trends in specific region for, in this case, the Mediterranean region, and maps of trends. This is, for example, the trend of the global ocean heat content anomaly. Is an anomaly with respect to a reference period. Our reference period is so far is 1993-2014, and these are this is the time series of the global average, so average over the whole globe of the heat content, of the heat contained in the uppermost 700 meters. You see the line here, but you see also the shaded area, okay? And the shaded area is exactly the spread among the products. So the uncertainty that is affecting this trend. This is the global average, but what is most probably most interesting for any of us living in different places is the regional trend of the ocean heat content anomalies. And this is the map of the regional trends of ocean heat content anomaly. Again, is an anomaly with respect to a reference period. So here you see where you see red. More reddish means that the ocean is absorbing more heat than in region where you see light red or pink, or even in region there are, you see, very small, but there are regions, very few regions like the famous North Atlantic, where actually we know that the ocean is losing heat and is not absorbing it. From the same map, I'm not sure if you can see it, but there are regions where there are a lot of dots, okay? And the black dots here indicate the areas where the noise, so the uncertainties among all our reanalysis is bigger than the signal. So it's bigger than the ensemble mean of the trend. So these are the regions where the reanalysis disagree more, okay? They don't agree a lot. They are not consistent. So these are the regions where we can be less confident of the value of the trends that we are looking at in this specific case for the oceanic content. I think this was my last slide. Thank you very much.
Thank you, Simona, for your presentation. Stay with us because we are probably going to need you for the Q&A session. We are going to have just 5 minutes of Q&A because we're running out of time. Sorry for the 10 minutes delay. Okay, so the first question that we're going to take is the one that has been the most voted. And it's, can your data be used for biogeographic prediction of marine species? I don't know who can answer this question.
I can.
Okay.
Vinca.
Hi.
Yes, they can. If you're looking at the modeling of environment and species behavior, they're using a number of CMEMS data, altimetry, sea surface temperature, or chlorophyll data. So yes, there are, and you have also biogeochemical models available, which are a step further.
Okay, thank you for
the physical model. Physical models can also be used as an input.
Yeah, also.
Okay, so we're going to the second question. That is, in fact, 3 questions. So how is the ease of using this product for teaching undergraduate students? Can the analysis be done offline in areas with poor internet? And are we able to access information about ocean just around us? And for question, is this product applicable for use with surface waters? So there are many questions here. Does someone want to answer?
We are using some of those data for kids, for primary and secondary schools, so undergraduate students should be able to.
Well, yeah, the answer to the first question, I think, is yes. Also to the second one, the analysis can be done offline as long as you know you can download the data and you have the computer facility to store them and to analyze them. It can be done. In areas with poor internet, well, that might be, cause a problem for the downloading because most of these products are quite heavy, let's say. They are quite an amount of data, so that can cause some problems for the download. But once you have downloaded the data, you can do whatever you need to do.
You may use the Wikio platform too.
Yeah, Right.
Because,
That's another,
you may use the Jupyter facilities on the Wikio platform to access the data and extract only what you need.
Exactly.
I'm not sure about the efficiency of this with a poor internet connection, but I guess this can help. Provided you have, well, it can be, you may have to pay something depending on what you want to do, but I think it's progressive.
Some of the data are also available through UMetcast. This is a satellite link. If you've got a station, which I think is not that expensive, you can download via a dedicated satellite link some of those data, not the whole catalog, but can be a backup solution if really internet is poor.
Okay. So I think we answered well this question. We can switch to the next one, maybe. So the question is, can you access data more than 3 years ago from CMEM's ocean products, looking for data from 2016? So before answering this question, I want you to know that if you want to access data that are not on the catalog, you can contact the service desk and they will put you in touch with the data producers. So don't hesitate to contact the service desk. Sorry. So does someone want to add?
Yeah, maybe, I can answer this, at least regarding the reanalysis. So the ocean reanalysis, both for the global and for the regional seas, all the data are available since 1993. Okay. So that's a long time series, from 1993 up to approximately a few months before present. This is for the physical and I guess also for the biogeochemical reanalysis and also for the reprocessed data, but I leave the specialist on observations to answer how long the data are available.
Mm-hmm. Regarding in situ data, we have data even from the 90s and even in the in the 80s, I think. So yes, although most of the data is available from 2010 onwards. Of course, the previous one is a little bit sparse, but of course there are data previous to 2016.
Okay, thank you for all these answers. You can see that we have plenty more questions, but unfortunately we won't have time to go to answer all these questions. As we said before, you will.
Ergane, you cut.
Sorry.
Just repeat what you said, please.
Sorry. So we don't have time to go through all the questions, but we will send you a file with the answers to all the questions.
Okay, so I think we will wrap up now. You can also go directly to the Copernicus Marine website, and there is a chat box where you can type in your direct questions, or you can contact the service desk at any time and ask all your questions, and you should get a response within 24 hours. So I think we're going to stop here. I invite you all to visit the Padlet and get accustomed to the different learning materials. The Padlet will be updated tomorrow with some new things. So please check them out. Tomorrow after tomorrow's session, we will also send out a link to a survey to get your input on how we can improve future trainings. So please please kindly participate in it. And yeah, I think that's about it. I think for tomorrow's session, maybe Ergane, you can present
Yes.
what we're going to cover
Yes.
tomorrow.
Yes, we're going to have a practical session tomorrow. So you're going to see use cases, well, how you can use the data that you've been presented by yourself. So with Panoply, Jupyter Notebooks, and QGIS. So this will be, again, a very, very interesting presentation. So we are very excited to see you there.
Okay, well, thank you very much, everybody. See you tomorrow at 10 a.m. CET, and have a very nice day. I'm going to stop the webinar. Bye. Thank you to our speakers.
Thank you.
Bye, everybody.